So when I built this furnace about 5 years ago, my intention was for it to be a fuel-fired furnace, specifically natural gas. And yeah, it's got a 15-inch bore, 9 inches high. It was made to accommodate my A60 crucible. And I used castable refractory for the interior components. And even though I used every effort to minimize that mass, it probably still has 175 pounds to 200 pounds of refractory in it. And that center section that you see is an 8 kilowatt resistive insert. I originally only intended to use that for heat treating, but since I'm an automotive parts caster primarily, and primarily cast aluminum, I've actually used it as a melting furnace for my A60, but with only 8 kW and that size and that mass of furnace, it takes a few hours for it to melt, 60 pounds of aluminum. So I've been so happy with my low mass, smaller electric furnace, I decided to convert this one over to being a larger resistive electric furnace and try to reduce the thermal mass of the refractory considerably while upping the power from 8 kW to 22 kW. So that's what this project's all about. I've got to take out the old refractory inserts that were in the furnace as a fuel-fired furnace and swap them with my new low mass inserts for the new version, the resistive electric version. So stay tuned. So hello everyone, this is probably one of the more challenging aspects of the project, and that is making the refractory hot face with coil shelves molded in. And the approach I took is similar to what I've taken on my other projects, my other furnace projects similar to this. And that is I used foam, go figure, to make the coil shelves. And I used that profile and glued it around the perimeter here, as you can see, for 6 coils. And the bore of the furnace is 15 inches. The OD is 22 inches. And it's 18.5 inches tall this direction, which are the same dimensions as my current larger furnace. But the refractory material I'm using, I'm kind of stoked about. The best thing to compare it to is I'd say it's like maybe K23 insulating fire brick, but it's moldable. It's like just a soft, pliable putty, and it air dries. And so this is a little mock-up I made. Now I'm going to probably try to apply this in layers, because at 1/4 of an inch thick, this dried in about a day. But this will be quite a bit thicker. And in fact, I was coming up with all kinds of elaborate schemes to give it uniform wall. And I think what I'm going to do is I'm just going to build it up to straight across and straight here on the flange. The stuff is low enough mass that even at 1.5 inches this way and 1 inch on the flanges, it'll weigh less than 20 pounds. So that's pretty light, and it's strong stuff. So to make the ID of the furnace barrel, I just use one of those quick concrete tubes. And anybody who's bought those probably knows they're all kinds of different diameters, because when they ship them so they can nest inside of one another. And all I did to get it the exact size I wanted to is I just cut a section out of it and then taped it back together this way, so it was exactly the size that I wanted. And I used other scraps out here on the ends for the flanges. And I mummified the whole thing in packing tape, and that's going to be my parting compound, if you will. But the plan is I'll apply that ceramic refractory in layers, and probably about a 1/2 inch thick at a time. Let each one dry, then apply the next layer, and so on. And I've already experimented with it a little bit. It tenaciously bonds to itself, so I don't think there's any problem with applying it in layers. And then you can see here's the profile of each of those foam strips there. So there would be the coil, and that little piece on top there that on this end I've got shaded. I figured at just different, like 8 locations around each ring, I'd just put a little wedge in on top of it, and that'll keep it contained in that groove. So one thing I've learned is that these coils, when you heat them, they expand a lot, and through lots of cycles, of expanding and cooling, if you don't have a good scheme for retaining the coils, they'll grow out of their shelves. And if you have to try to stretch Canthal after it's been fired, chances are pretty good you're going to break it because it gets brittle. So that's my plan for it. And I guess all that's left right now is applying a lot of that ceramic refractory and giving it a lot of dry time. So I'll let you know how it goes. Hopefully I can get it to stick to the plug as I coat it, all the way around. But we'll find out shortly. Stay tuned. So to help dry it out, I've got this little muffin fan forcing air, and I've got that brown piece of butcher's paper around as a shroud to force the air around the outside of it. And we got this little PID controller here and solid state relay set on 55 degrees centigrade. And inside of here, there's a light bulb in there controlled by that controller, 200 watt light bulb. So that's what's providing the heat inside and moving air across the outside, and I use that as my drying rig. So even so, I used it for a few weeks to get everything as dry as I could before firing it. So for the base and for the lid, I had this piece of 20-inch by 40-inch by 4-inch thick, 2600 degree rated ceramic fiberboard, and I bought it 5 years ago. It must have been mislabeled, mispriced, because I got it for 40 bucks shipped to me, which had to be probably about what it cost to ship it to me. But I had it for 5 years. I bought it for a different purpose, and I looked at it and I said, this would be just perfect for that big furnace floor and the lid. The stuff's super light, super high insulating, and unlike the furnace body for all the electric coils and stuff that I had to mold, and it took all that calendar time to dry, I literally took about a half an hour to make this, and it went so fast. All I had to do was cut a little segment like this and glue it on to the base, because the base is 22 inches in diameter, and I couldn't quite, it wasn't quite wide enough to do that, but there was plenty left when I positioned the two circles on it to make the segment. And I got a few offcuts like this. You can see, how thick it is, and I just cut it on my bandsaw. I put a mask on, and then I just kind of scraped up all the fines that I could. And then what little fines were left, I vacuumed up on that. But it was quick and it was easy, and I think it's going to be a really lightweight and very insulating lid. And this ceramic fiberboard, it's not penetrated by and it's unwetted by aluminum. So if you spill aluminum or splash aluminum on it, it just comes right off on that. So these offcuts, I'll get to cut some of my tool plugs. We'll see that later. I've got to cut a little hole in here. I got a hole saw to do that with. This ledge, I just used a razor knife and just cut this way and cut this way by hand, and it cuts pretty easy with a razor knife. So stuff's easy to work. I'm glad. And finally, I got it off the shelf after it being, in my rafters for 5 years. So it's a good purpose. So now it's time to start swapping these pieces and the furnace body in my old lift here sitting behind me. And I'm going to do that because I'm going to use the electric insert in that to do the final curing on both these and the electric insert for the furnace body. So stay tuned for that. All right, so I took the molding end caps off, and I used the ceramic fiberboard, the thick ceramic fiberboard, to make the lid and the base. And I left the cardboard tube in there, but at 100 degrees, it activated the glue and it just sunk down there. I don't know if you can see the display or not, but it's set on 100 degrees centigrade. It might be strobing a little bit, but that's what it's set on, and that's what it's sitting there at. So I'll let it set at this temperature, probably overnight. And then tomorrow I might just pull the cardboard out of there. I mean, if it's loose, why not? And anyway, so on with the curing. All right, I thought we'd just take a quick look at the main furnace body. This I took some time, and you saw the plug, and I built that all up by hand just by troweling on that moldable ceramic putty, and it came out really nice. And the only thing left to do, I mean, it's cured about as good as you can get it to green state. I used a 300-watt light bulb and sat it on top of the base with the lid on it and let it cure at 100 degrees centigrade for, I don't know, it must have been a week. After a day or two, I think it was probably as cured as it was going to get, but I had other things to do, so I just let her go like that. And the only thing left to do is fire it, and you can see I haven't taken or tried to take out the styrofoam electric coil shelves, the styrofoam that was used to form those. I figure I'll just burn that out when I cure the rest of it. There isn't any sense in spending the time to do that, or potentially damaging, the coil shelf and that, when it'll just cook out and just turn to white ash and go away. So I'll get the outside of it here, the little pockets will get filled up with ceramic wool, and then I'll put it in the furnace body and get the new floor and the new lid in my furnace lift, and we'll go ahead and fire it and get it cured up. Stay tuned. So there are the old refractory inserts. There was a base, furnace body, and lid, a very fancy lid. I'll insert some pictures for you if I haven't already done so, for you to take a look at on that. But they're out of the furnace, and now I'm swapping in, the task is to swap in the new low mass components that I just recently fabricated, and then fire them. So I'll do that swap and then fire them, and I'm going to use that 8 kW electric insert to fire the new furnace body with the coil shelves in it, and we'll have a look at what I have afterward. Stay tuned. All right, well, I did that swap, and then I took about a whole day to ramp the temperature up to 2000 degrees Fahrenheit to cure that moldable ceramic refractory, and to burn out the styrofoam coil shelves in the midsection of the furnace. And let's take a look at what we've got. And while it was hot, there weren't any cracks, but when it cooled down, I did get a couple of pretty significant cracks. One there at the top, which is where it's the thickest, and perhaps the worst one is just opposite of that here on the other side. So I'm not really sure what I'm going to do about that. I mean, some cracking is to be expected. It's because the inside expands so much more than the outside, because the inside's at 2000 F and the outside's basically at a couple hundred F. And that makes for quite a bit of stress build up in that monolithic block that I molded there. But I don't know, I might dig out the crack and patch it, but I've got a sneaky feeling that even if I do, all it will do is reappear. So I think I'll just put a metal case on the outside of it that keeps everything in compression and just build it out. But got a little bit more finishing to do on it. But yeah, that's the biggest part of the project behind me here. The rest now is just on to the rest of the build out, and mostly just building the electrical controller and heating elements for it. So stay tuned for that. All right, everyone, I'm back with you. I got some time shook loose to work on the furnace, and you could probably tell from the preceding picture, I've got the refractory work done. I put in these feed-throughs right here for the heating elements, the individual heating elements. They go through to the grooves on the interior coil shelves. And as it works out, there's about 1 3/4 of an inch of the refractory material that I use to form the structure, and about just under 2 inches of wool. So it's just under 4 inches wall thickness, about 3 3/4, I think. And take a look at the interior here. Did a little light patching here and there but you get the idea. So it's ready to, I'm going to put a sheet metal skin around the outside, and that sheet metal skin will have to have mouse holes cut in it for these feed throughs. And then that whole thing slips into my furnace lift as a module. And in this case, because I want to run the heating element extensions outside the furnace to a cool region, I'll actually have to install the heating elements while the module's in the furnace, because they won't be able to be extracted from the furnace lift with them in place. But anyway, I need to get the sheet metal made for the outside, and we'll stop back and take a look after I get it skinned. Stay tuned. So with the resistive heating elements installed, I needed some way to connect them to the electrical conductors. And so I bought these little ceramic junctions here that you can probably see. Hopefully I'm not sure what the metal is in there. I'm sure some kind of copper alloy, but hopefully that they'll do the trick here. But as you can see in the raceway, what happens there is there's the twisted triples, if you will, of the heating elements connecting to one side, and then that's appliance wire, high temperature appliance wire there. It's actually, I think they call it MGT. It's a mica insulated nickel-clad copper wire, but it's rated for 900F, and that is what connects each individual element up there to these junction blocks, and that's where I'll bring in the main power. And the way they're wired is that there's two banks of approximately 11 kW each. That is every other coil heating element as you go up the furnace wall. So I can run half power or full power, or run either or of the 3 heating elements at a time, or run all 6 of them. So yeah, so now I'll button it up. I've got a little perforated plate cover for that, and a top for the raceway to bring the wire in, and it'll be ready after that. So it'll be on to the electrical controller. Stay tuned. All right, well, the furnace conversion is complete. I got the coils wound, installed, and then the coil shelves here, you can see what those look like. I put these little wedge blocks in at every 45 degrees in each shelf to retain the coil in that groove. And if you get a little bit of a close-up there, you can see those blocks in there all the way down. And then of course I put the ventilated cover, perforated plate cover on the raceway, the electrical raceway, for connecting the power to the kiln elements. And that little part there on top is where the cable will come in. So yeah, basically what's left right now, that is to make the electrical controller, actually assemble the electrical controller, and then get my shop service ready for it, and we're ready to cook with it after that. So on to the electrical controller, and I'll rejoin with you then. All right, well, I've got all the little castings, the heat sink and the 2 receptacle boxes ready to go. So I'm going to go ahead and cast those up. And after I do, then it's pretty much finish assembling and finishing up the control box. So stay tuned, and I'll get these cast up and we'll have a look. Well, everyone, back with you here, and I had a little casting session today. And those patterns that you saw in the pictures got turned into metal. The first one here is the heat sink, and this actually goes on top of the control box, and I haven't cut all the gating off it yet, but I'll just set it on the mill and mill those 2 pieces, those 2 thin strips off there. And then those raised pads that you see are for the solid state relays to get mounted on. And then the heat sink itself then just sits right on top of the control box, and that keeps those solid state relays nice and cool and happy and hopefully long lived. And then the other two castings are the receptacle boxes. For this one is the receptacle on the control box, and you can see here it's an elbow with a flat mounting pattern there and a raised boss to accept the receptacle there, like so. And then the whole thing gets mounted on the bottom of the control box like that. And there's a mother of all drop cords that connects to it to power it up. And then this, of course, is the same thing, only it goes over by the my 200 amp service. So it's just got the mating end of the receptacle on it for the power on that, and I'll have it'll be 100 amps, so there's plenty of pucker for me. 100 amps is a lot of power, and wait until you see the cables for that drop cord that goes between the two. It's it's 4 conductor number 2 gauge SOOW cord. I'll get that into the build here a little later, but so at this point, it's pretty much all assembly. You can see in the background, I've got the components mounted in the control box. We'll have a closer look at that when I get it all wired up. But yeah, it's pretty straightforward now. Just go to it and wire up all the components, and I'll be getting pretty close. Stay tuned. Well, so now it's time to find a place to draw another 100 amp circuit off my main service panel. You can see here I've got a 3-phase converter and a 3-phase panel, and on the other side of the door there I've got another sub panel in that, and I got this 200 amp service, and obviously you add all that up and it's way more than 200 amps, but you know, I rarely are using more than 1 or 2 circuits at a time. But although my contractor, when I did my shop, laid everything out very nicely, he was pretty generous with the allocation of space here. So I've only got 1 slot left, and I need 2 for a 100 amp breaker. And the obvious one to me is going to be these 2 here, because the lighting in my shop and the bathroom will never be loaded by more than what's on that circuit, and they're lightly loaded as it is. So I guess all it means is I just need to move up or move down these 2 breakers here to make room and put in a tandem breaker, and then I'll be there. So anyway, my plan is to put that plug right here, right next to the box, and that's the task at hand for today. So stay tuned. All right, I got the breakers moved around. I've got the receptacle installed here. So now I've got some place to plug my mother of all drop cords into. And there's that 100 amp breaker for it. So, yep, I got a full panel, and I'm ready to rock and roll. So I'll have to plug everything in and do a smoke test here. Stay tuned. All right, well, back with you, and hopefully coming down the home stretch here with my service panel adapted to provide a 100 amp receptacle for the furnace, and the furnace controller made and the furnace completed. I just need a means to connect the 2, and that's what I've been jokingly referring to as my mother of all drop cords, which I've got 35 feet of 2-4, that's 2 gauge 4 conductor SOOW cord, and then the corresponding male plug for each, and female plug for each end. So would I have had to have had 2 gauge? Well, 2 gauge is probably overkill, except in SOOW cord, it gets derated because it assumes that every conductor is energized at 100 amps. And I've been saying 100 amps, it'll actually be closer to 90 amps on that. In my case, there's actually only 2 of the 4 conductors energized. The reason I went with 4 is I do have a couple of 120 volt accessories on the control box and a 120 volt accessory outlet that I wanted to be able to operate off that. So I ran the extra leg for it. And then of course the 4th one is ground on that. So anyway, for 35 feet and line drop, it's plenty sufficient to be sure. And the difference between 2 gauge and 4 gauge in cost wasn't that much. So it was cheap insurance for me on that. So I just need to install the plugs on each end, and I think I can connect the controller up and see what we've got. Stay tuned. Well, all right, I just fired it up, and for the first time, and I don't know if you guys will be able to see the LEDs because they tend to strobe, but it's set on 700 degrees Fahrenheit. It's going up rapidly at about, I'd say 10 degrees per second. It's an empty furnace. And then it says I'm drawing 87 amps at 238 volts. So that's just under 20 kW. It's cycling, I see it just overshot 700, so the solid state relay is kicked out, and the heat of all those coils in there made it overshoot 700 by about 50 degrees. But wow, that was less than a minute. It just rocketed up there. So we got some power here. I'll have to play around with it a little bit, but so far so good. Stay tuned. Well, here we go, just running it up to 1500. See if you can get the power and current readings, voltage readings. So I decided to measure the temperature of the furnace in 2 places. One in the typical location where I have been with my newer heavy gauge probe there in the center. But I also put a probe right out near the furnace wall, basically in the gap, the annular gap between the crucible and the furnace wall, because I suspect it's going to be quite a bit hotter out there than it is right above the 40-pound charge of cold aluminum in the crucible. So we'll see how it tracks. Well, I'm sure you probably can't see the PID because it's strobing, but you can see the handheld meter there. That's the gap between the crucible and the wall of the furnace. That's where that's being measured. And you can't see it because it's strobing, but it's lagging about 300 degrees behind the gap between the crucible. And that's being measured at the center of the lid, or basically at the top of the crucible, where that crucible is full of a 40-pound charge of aluminum. So after about 10 minutes here, that gap, that annular gap between the crucible and the wall is at 1200 degrees plus, and the center of the lid above the crucible is at about 960 degrees. So the temperature's rising pretty fast. We'll have to see how long it takes to get to melt. Stay tuned. All right, everybody. Well, we're skimmed and ready for the pour. We got 40 pounds of molten aluminum in the A60, and it's at 1375 Fahrenheit. Let's see if I can grab it and pour the mold. right, well, I had a little smoke there at the very beginning of the pour until I got the cup full, and then it settled down and seemed to take metal very nicely. So hopefully it's a successful pour. We'll wait for it to cool off for a little while and demold and see what we've got. Stay tuned. Yeah, let's see. We'll just have a quick look at what an 1800 degree furnace looks like here. Yeah, she's bright orange, so that's a hot one. So I just got finished with the pour and thought I'd do a quick little walk around tour of my big pouring rig here. On the right there, you see that's my vibratory flask. My big one is basically a 30-gallon barrel with a extender on it. And then of course above it is this my gantry crane. It's got a little power hoist there you can see on the top, and it's attached to a shank that can grab, that's got active jaws with a over center locking lever that can grab my A60 crucible. This is what that actually, it's an IC60, it's a bilge crucible on that. And then I just now converted my large furnace here to a low mass 22 kW resistive electric furnace. So we can take a quick look at it here, but the lift mechanism, it's a lift-off furnace, as you can probably see, and it's counterbalanced. These weights counterbalance the weight of the furnace, so even though I've got this electric actuator on it to lift it, if that wasn't there, you could still lift it with your hand. It's basically weighs effectively nothing with the counterweight, but it makes the job a lot easier for that actuator. This is my contact pyrometer here, so that's an immersion pyrometer that I measure metal temperature with, and I move that around my equipment, and I just use a handheld connected to that. But the control panel here is fairly simple. It's got a main power button, it's got a PID. This is actually a Wi-Fi enabled PID, and not only is it nice to be able to measure or view your temperature readings remotely, you can key them in, which is huge, keying them in on the app, because you don't have to stand here with your fingers on the buttons for minutes at a time when you're making big moves. And then this here is there's a big contactor inside that applies power to the resistive coils in the furnace. So anytime I'm going to put my hands in that furnace, I de-energize the whole furnace, so I can't be shocked on that. And then this switch and pair of switches and lamps, they actually open the circuit between the PID controller and the solid state relays, so I can turn them off this way. So when I go to reach my hands in the furnace or put tools in the furnace, I not only turn off the SSRs, I open up the contactor, because the SSRs only open one side of the US 240 volt circuit. The other side's still 120 above ground. But when I open the contactor, it opens both sides. So this up here, and I'm sure you can't read them because they're strobing, but this power meter gives me voltage, current, power, and energy consumed. And I just melted 40 pounds of aluminum in 55 minutes, and it says I used 20 kilowatt hours to do that. So at my rate, that's probably about $1.80 that it cost me to melt those 40 pounds in 55 minutes. And if we just take a quick look inside, that's all the instrumentation. There's a fair amount of wiring there, but basically all there is a 100 amp circuit breaker there on the left, and this large NEMA size 4 contactor. It's 90 amps when it's running full bore with all 6 coils running on it. And that little shiny thing in the middle, that's actually just a DC power supply to run the actuator on the furnace lift. And if you look up in there, you can see the 2 solid state relays. They're 80 amps, but I'm only pushing them at about 45 each. And on top here, I cast a heat sink to cool that, and the PID is controlled by a K-type thermocouple there that I run back into the control box. So outside of that, I've got what I call the mother of all drop cords. Here you can see it's actually 2 or 4 conductor 2 gauge SOOW cord with connectors on each end. I got 35 feet of it. It's running into the shop there. You can't see it, but that thing weighs about 55 pounds by itself. But I can disconnect it here from the controller and disconnect it from the receptacle near my main power service and hang that thing on the wall so I don't have to deal with it all the time in my shop. So anyway, that's basically it. That's my large pouring rig, and hopefully here in about 15 minutes, I'm gonna dump that barrel, that flask on the right on the ground, and pull out a intake manifold. We'll see. Well, and happy day, happy news, got a good casting. So we're just letting that puppy cool off. And then we'll maybe degate it and clean it up a little bit and take a closer look. Well, let's see how it looks after the first real use. It looks pretty much just like it did beforehand. The coils are a little oxidized as they should be, but yeah, everything went well. I'm sure that over time I'll be making little tweaks to it and little improvements here and there. I always do. We'll take up with another video on that intake manifold that I cast. Be sure to look at the links in the description on the build here. And also visit my channel. I've got all kinds of lost foam casting projects that I've done with this and my other smaller version of this furnace. So until next time, thanks for watching, and we'll catch you on the flip side.